This question is about the uniform circular motion in which it says that a ball that is attached with a string and this ball is moving in a horizontal circle. All right. So, what is a horizontal circle? And it is moving with a constant speed. Why it is not moving with a constant velocity? Let me quickly tell you what do we mean by the horizontal circular motion. So now I'm showing you this horizontal circular motion in our Cartesian coordinate system, in which if you see, this is our horizontal plane, which is basically xz plane. All right. So this is the xz plane. So if the object is moving in a circular motion, which is a horizontal circular motion, so at every point, and for example, at this point, the velocity will be in this direction, and at this point the velocity will be in the opposite direction. So because the direction of the velocity is changing, that's why we can't say that it's moving with a constant velocity, but the magnitude of velocity may be a constant, and if of course it's a constant. Okay, now in this question we have to find out the horizontal component and the vertical component of net force, the resultant force. And once again, we will draw the free body diagram to determine how many forces are exerted on it. So students, it is moving in this circular motion. All right. Now, how many forces are exerted on this? The one force that is obviously due to the, it is attached with a string, so that must be the force of tension. All right, ft. And the other force must be the weight. Now remember that the weight at this in this question is smaller than this, so mg is a smaller than the force of tension. And what is the reason is that if you see this angle, all right, theta, so this angle is also theta. So one of the component of force of tension, okay students, the one of the component of force of tension is equals to the weight. That's why the force of tension is more than the weight, and that component is obviously force of tension cos theta, because that's adjacent with theta, and you can also determine it trigonometrically. What is the other component which is in front of this, and it is towards center? So that is a force of tension sine theta. Okay, so now you see very clearly that the upward force and the downward force, these two are balanced. So what about the resultant force, sum of all forces along y-axis? So that must be 0. Why, dear students? Because the upward force minus downward force are balanced. And what about the forces along x-axis? So there's a one unbalanced force, which is ft sine theta, which is basically the centripetal force in this question. Or as it is written in this question is the T, right? Tension is written by the T. So that's a T sine theta. So our right answer should be T, because the vertical component is 0 and this is T sine theta.